Most of the chemical reactions that we've looked at so far have been irreversible reactions. Here's copper patina. It's an oxidation that happens to copper where a new compound is formed. Similar to the rust that you'll see on iron, you normally won't see something unrust or turn back to the shiny metallic surface that it used to be. These reactions are called irreversible reactions because the reactants react to form product and no product reacts to form the reactants. These reactions are said to go to completion. This means that the reactants react completely to form the products and there is no reverse reaction taking place. The forward reaction continues until it can no longer occur because one or more of the reactants are used up. These irreversible reactions have a one-way arrow. If we're looking at the zinc and hydrochloric acid reaction, the zinc reacts with the hydrochloric acid. There's leftover hydrochloric acid, but all of the zinc has been used up and forms zinc chloride. The hydrogen has escaped, so you cannot have a reverse reaction if you can't have your hydrogen product become a reactant. It's escaped. Here are other irreversible reactions. Combustion reactions are irreversible, and reactions that form a new precipitate are also generally irreversible. Some chemical reactions are called reversible reactions because under certain conditions, the reactants can react to form products in the forward reaction, and at the same time, products can react to form the reactants in the reverse reaction. Collisions of the reacting molecules cause chemical reactions in a closed system. Sometimes the product molecules collide in such a way that they can react to form reactants. Sometimes the reactant molecules collide in such a way that they can form products. Reversible reactions do not go to completion. Instead, they go to equilibrium, a state in which the rate of the forward reaction and the rate of the reverse reaction are the same. At equilibrium, there will be some of each reactant and product present. Here we have the synthesis of ammonia. Under certain conditions, ammonia can react to form the reactants, the reverse reaction. Here we have the reactants before the reaction has started, nitrogen gas, hydrogen gas. You give them a certain amount of energy, certain conditions, and at the beginning of the reaction you can see the hydrogen, nitrogen coming into contact at a certain orientation with a certain amount of energy to react to form ammonia. At equilibrium, there are some product molecules, ammonia, but there are also some reactant molecules, hydrogen gas and nitrogen gas. At equilibrium, the rates of the reverse and forward reaction are the same, and the concentrations of each reactant and product will remain constant, given the same conditions. The reactions have not stopped. The rates are simply the same. So once you have a certain amount of your nitrogen, hydrogen, and ammonia, it doesn't just stop happening. You continue to have a forward direction of reaction and you continue to have your reverse reaction. So your reactants get eaten up to make your product and your product decomposes to make your reactants.